Hi everyone, so we're in section 1.3 part 2. I just want to split it up a little bit for you. So we're getting ready to talk about two really important topics, midpoint and bisector. All right, so midpoint. If you didn't know what the word meant, I hope that you start breaking things up into pieces. So I'm looking at this and I see mid. I see the word mid in midpoint. And mid to me means middle. And that's exactly what midpoint is. It's the middle point of a segment. It's the point that's in the middle of a segment. So if a point is in the middle of the segment and M is the midpoint, then it divides the segment into two equal or congruent segments. So if I tell you that M is the midpoint right here, then I know that AM is equal to MB. And I can mark it with the hash marks. All right, so if I also see something and if a point divides a segment into two equal parts, then it actually is the midpoint. Now we want to be really careful here because we just got started talking about the segment addition postulate. Remember I said that B was like between, when there's a segment between A and B, that it might not necessarily be the middle. So we want to make sure that we don't get confused between when I use the term midpoint versus segment addition. All right, so how can we use this? Well, let's look at the example. Point M is the midpoint of segment VW. It wants us to find the length of VM if Vm equals 4x minus 1 and Mw, the distance, equals 3x plus 3. Show all your work, it says. When we don't have a diagram, I said in the last video you want to draw one. So I'm going to draw a segment VW. And as soon as I know that M is the midpoint, I'm going to put an M in it. I'm going to mark the two parts congruent. Okay? All right, then it told me that Vm was 4x minus 1. So I'm going to label 4x minus 1. And it said that MW was 3x plus 3. Remember, if things are congruent, then that means they are equal. So to solve for x, I can actually set the equations equal to each other. Now you want to really carefully look at the difference between the segment addition postulate and this. Segment addition, I added the two segments together. This one, I'm setting them equal to each other because they are equal segments. All right, so then I'm going to solve. To balance the equation, I'm going to add the 1 over to the other side. I'm going to subtract the 3x to get x isolated, and I get x equals 4. I go back to my question. It says find the length of VM. I got an x. So now what I got to do is I've got to substitute x into the expression 4x minus 1. So I'm going to plug the 4 in for the x. And I'm going to multiply 4 times 4, which gives me 16. I'm going to subtract 1, and I'm going to get 15. So VM equals 15. I'm going to clearly state my answer and box it. Okay, that is midpoint. Now we're going to talk about the word bisect. Not dissect, but bisect. Bisect. Sect means to section something off. Actually, it's a Latin word. But so when we use the word bisect, it means cuts. Okay, it cuts it, and the word bi means two. So it cuts it into two equal parts. Okay, so I could bisect a segment. I can bisect an angle. I can bisect a triangle. Bisect cuts it into two equal parts. So we could say that the midpoint, that M is a bisector, but it's a segment bisector is a little bit different, okay? So a segment bisector is actually a line, segment, or ray that cuts a segment at its midpoint. Okay, so I'm going to show you what I mean. Here's a segment AB, and I'm going to tell you that M is the midpoint. If a segment bisector, I'm going to do something like that, going right through it. If that bisector, if that line bisects at M, AB at M, which is the midpoint, then it is a segment bisector. Okay? Now, it does do the same thing. It cuts the segment into two equal parts. But it's a little different than what the actual midpoint is, okay? So I want you to, tonight, think about how you could convince me they are different. Just think about it. Could you convince me that they're different? And how would you do that? All right, guys, have a great night. See you tomorrow.